This series of videos is about complex numbers. Complex sounds a little bit scary. Complex sounds like complicated or causing a lot of trouble. But it ain't so. Don't be afraid of complex numbers. It's easier than you would think. Let's do a little bit history of mathematics. In mathematics, everything begins with the natural numbers, many thousand years ago. And later, in the 16th century, people added the zero and the negative numbers to the natural numbers. So the new system is the system of integers, written Z. In the integers, you can solve equations such as 5 plus x equals 2, because the solution is a negative number. But still, in the integers, there are equations that cannot be solved. For instance, 5 times x equals 2, because the solution is a fraction. So fractions are added to the system of integer numbers, and we obtain the system Q of the rational numbers. But still, in the rational numbers, there are equations that cannot be solved. For instance, x squared equals 2. The solution, square root of 2, is not a fraction, it's a non-periodic decimal number. So adding numbers like square root of 2 or square root of 3 and so on, we obtain the system of real numbers. And the system Q of rational numbers is a subset of the real numbers. So in each step, the systems are augmented by new numbers. Now we have still a type of equations that cannot be solved in the real numbers. For instance, x squared equals minus 1. In school you learn that equations such as x squared equals minus 1 are unsolvable. But mathematicians can solve it. They just invent a new number, I. I is not a real number, and I stands for imaginary. And I is the solution, one solution of this equation. The other solution is minus I. With the help of these imaginary numbers, we can solve a lot of quadratic equations. Look at the following example. For instance, the equation x squared equals minus 25. The first solution is 5i, because 5i squared equals 5 squared times I squared. 5 squared is 25 and I squared is minus 1. So altogether it's minus 25. The second solution is minus 5i, and the argumentation is the same, because minus 5i squared is minus 25. So in short form written, it's x1, 2 equals plus minus 5i. Now a more complicated type of quadratic equations. X squared plus 2x plus 5 equals 0. In order to solve these equations, we use the PQ formula. And if you have forgotten the PQ formula, you should just look at the internet and you will quickly find it. The formula, PQ formula, says the solution x12 equals minus p half, which is minus 2 half, is minus 1, plus minus square root of p squared divided by 4, which is 4 by 4 is 1, minus q, so 1 minus 5, and altogether this is minus 1 plus minus square root of minus 4. The square root of minus 4 is 2i. So we have the two solutions, minus 1 plus minus 2i. So in order to solve quadratic equations, we need so-called complex numbers of the form a plus bi. A and b are real numbers. And if we have these complex numbers, we can solve all quadratic equations. Now you should stop the playback and try to solve the following equation: x squared minus 2x plus 10 equals 0. A complex number, z, is a number of the form z equals a plus bi, where a and b are real numbers. So a complex number is just sort of an object with two components, a and b. The first component and the second component both are real numbers. A, the first component, is also called the real part of Z, and B, the second component, is also called the imaginary part of Z. And when we write variables for complex numbers, we usually use the letter Z. And the number I satisfies the equation I squared equals -1. The set of all complex numbers, so all numbers of the form a plus bi, where a and b are real numbers, is called C, or written C with a double stroke. And real numbers are part of the complex number. That means every real number is a complex number. For instance, -7 is the complex number with real part -7 and imaginary part 0.